going to go ahead and take a look at number 99 from section 1.3, which dealt with quadratic equations. The problem reads as 5 over x is equal to 4 over x squared minus 6. And the directions read, change each rational equation to quadratic form and solve it by the most efficient method. So with regards to this problem, notice that you have fractions here. We're going to use the same methods that we had worked with when we were solving radical equations in section 1.1. So what I want to do is I want to find a common denominator. Okay, and note that if you were to write each of these as fractions, you would have a denominator of x, a denominator of x squared, and a denominator of 1. So take a couple minutes, pause the video, think about what is the least common denominator between x, x squared, and 1. So now that we've kind of looked, so we have a denominator with x, a denominator with x squared, and a denominator of 1. I would say the least common denominator that we're working with should be x squared. I can easily change and manipulate each of these fractions to have a denominator of x squared. So what I'm going to go ahead and do then is I'm going to multiply each term by an x squared. And this allows me to go ahead and clean things out. So one of the x's in the denominator will cancel with one of the x's in the numerator. So this is going to leave me with just 5x for my first term. Then as we go through, the x squareds will cancel out each other entirely. So my next term will be 4. And then I'm left with 6x squared. So right now what you guys have is, it's almost a jumble. It's a jumble of terms. And in algebra, you are free to manipulate the outward expression. Okay, so what I'm going to do is I'm going to reorder this. So I will go ahead and subtract 5x from both sides. So I have 0 is equal to 4 minus 6x squared minus 5x. And really what I'm going to do is I'm just going to reorganize this. So I'm going to put my leading term first, followed by my middle term. And then, since there's no sign out in front of this 4 right here, it's positive. So that's why I have a plus 4 here. Okay. So again, you have several different ways to solve this problem. So you could factor, you could complete the square, or you could use your quadratic formula. In this case, especially if you're pressed for time, I would suggest using your quadratic formula. So I know that my a is negative 6. My b is negative 5, and my c will be positive 4. And also recall what the formula is. I'm about to set it up. Mouth it with me or say it with me. We will say negative b plus or minus square root of b squared minus 4ac all over 2a. So we'll go ahead and plug these values in. So we have a negative 5 plus or minus the square root of negative 5 squared minus 4 times negative 6 times 4. This is all over 2 times negative 6. Okay, let's continue working. So we have a negative 5, so this becomes positive 5. It's just a shorthand, cleaner to work with. I know that negative 5 squared, notice that I did put parentheses around that negative 5 because I want to do negative 5 times negative 5. So I will have positive 25. And if you do negative 4 times negative 6 times 4, that's going to give you a positive 96. And this is going to be all over a negative 12. Okay. So as we run through, then we have 5 plus or minus. Let's clean up our discriminant, or the radicand, or the number underneath the radical. And this is going to give us 121 all over negative 12. This then, we can say 121 is a perfect square. 121 is 11 squared. So we can say the square root of 121 is 11. Okay, so here I'm going to go ahead and break this off into two cases. Okay, I'm going to take it out of that shorthand. One of these cases is going to be 5 plus 11 divided by negative 12, and the other one will be 5 minus 11 divided by negative 12. Okay, so if I clean this up, I'm going to get 16 divided by negative 12, and we can reduce that expression down. So this one would become, what? Negative 4/3. And this expression would become negative 6 over negative 12, or positive 1/2. Okay. There are your solutions. Again, you could plug those values back into the original problem and make sure that you get true statements out to prove that you have solved this correctly. All right, there you go.